Widefield calcium imaging is a technology often used to record neural activity over the millimeter to centimeter scale. This method can provide a large-scale view of the dynamic brain, allowing researchers to map different brain areas and identify mesoscale dynamics like traveling waves.
Widefield calcium imaging is often implemented with a tabletop design, including a scientific camera and tandem lenses. When applied to behaving animals, this can lead to challenges. Head-mounted microscopes offer an excellent opportunity to record dynamics during behavior. However, most miniature microscopes are designed to resolve individual neurons and have a relatively modest field of view. In this video abstract from the December 5th issue of Neuron, we describe a new resource for wide-field calcium imaging in freely moving animals. We wanted a system that would allow researchers to record large-scale dynamics during natural behaviors like sleep, navigation, and social interactions. So we developed cScope, a head-mounted cortical macroscope light enough for a rat to carry.
So we designed cScope with three key features in mind. It should have as large a field of view as possible, it should be open source, something you can fabricate in your own lab, and it should have a two-channel illumination system for simultaneous calcium and intrinsic imaging.
The imaging field of view we developed was over 30 square millimeters. This area was sufficiently large that we needed a new way to deliver calcium sensors in rats. In parallel, we produced transgenic rats that express the genetically encoded calcium sensor GCamp6F in cortical neurons.
While transgenics move through their environment and interacted with others, cScope allowed us to image multiple cortical areas simultaneously. We also use cScope to measure calcium dynamics as rats solved a task designed to test their visual working memory. In this movie, you can see the flow of activity from the visual cortex to motor and somatosensory cortices during the task. If you are interested in building cScope in your own lab, follow the link in our manuscript to our GitHub site, where we provide a parts list, files for 3D printing, and a detailed user manual. The rats are available at the Rat Resource and Research Center.
cScope and GCamp expressing rats allow several new avenues for research. Together, they can be used to generate cortical maps during many interesting behaviors, providing new targets for future cellular resolution and circuit-level experiments.